This conference will now be recorded.
Hey, all right. Thanks everyone for joining. And I know it's a Saturday morning. And okay, so by the way, for those who are just joining the workshop for the first time, my name is Adam. And basically, what we would be doing today is, in the market, you've been hearing a lot about Kubernetes being used for deployments. But however, when we say deployments, what exactly we do, right? So you write some manifest file and then just you deploy. So that way, let's get a little deeper and try to understand what kind of problems that we have in our traditional method of using CI/CD, wherein we use Jenkins or some tool like GitLab, or you write some scripts, and even people use, maybe Ansible also to do deployments. But what are the problems, and is it the right way? And considering the market's requirement, how is that you should look towards a cloud native solution? So it's not just sufficient just by giving a solution, but it should be more operational excellence and, as I said, a cloud native solution. So that's what we will try to understand. And in that, the pretty much one of the recent best practice, which is kind of getting very popular in DevOps, is GitOps. It's actually a very simple subject. The only thing is, you would realize later that, hey, this is something which I'm doing, but the only thing is, were you doing it properly? So that way we will understand what exactly is GitOps. And in order to implement this GitOps on top of our traditional CI/CD method, so there are different tools available. So out of that, for the demo purpose, I'm going to pick up a tool called Argo CD, which is simple and lightweight. And we'll just do some comparison between others also. And finally, we'll get into more hands-on because I don't want to just talk only theory. I want to actually do certain things. So let's take a simple web application, maybe a stateless application, and we'll try to see how is that the deployment happens and how the whole concept of GitOps goes through. So that's the agenda for the session today. And based on how it takes, we might also have another session tomorrow. All right. And for those who are first timers, and if you are not aware of any of the basics, so I would suggest to go to my channel, and there's plenty of videos for beginners wherein you can learn pretty much Linux, scripting, version controlling system of Git, basics of Docker, build management. All those things are available. But I do expect for those who have joined here, you have some knowledge of what do you mean by CI/CD, and what do you mean by Kubernetes, or even something about version controlling system like Git. So I'm not going into basics of that, but by assuming that you know these basics, I'll jump on to the internals of all this topic. Okay, so with that, let's come to our CI/CD pipeline. Okay, so when I say CI/CD, what is that we do? So we all know that whenever there is a change which a developer does, immediately we are going to start doing a build for which there will be a pipeline. So honestly, if you see, CI/CD pipeline is not a single pipeline. Okay, so it would be basically divided into at least two pipelines. So what do you mean by two pipelines? So there will be one pipeline in which, based on whenever a check-in happens, you take the code, you build the code, and then if we want to deploy it, this is where on the modern deployment, rather than doing everything traditionally, we convert the application into a Docker-based application, which is nothing but creating a Docker image. So we take the application and add it as a Docker image, and this image we will be storing into a registry by using some tags or version. Now, how is that this image will be deployed? So this is where we use Kubernetes for orchestrating these containers among a group of machine or a cluster machine. Now, once again, what do you mean by deployment in Kubernetes? So basically, all you have to do is take this image and run inside the cluster which is maintained by Kubernetes. That is what we call it as deployment. Because once my container is running, I will have my application also running and you can start consuming it. But to manage that, we use Kubernetes. So that is where we deploy this image into a cluster or a group of machine managed by Kubernetes. Okay, but how does that happen? Anyone? Now I'm telling you first half. So how do you do this second half? So I have built an image. So my requirement is now I want you to deploy into a Kubernetes cluster. So what is that you will do for this? Is my voice audible to everyone?
Yes, by using object daemon set.
Okay, you still didn't understand the question.
Yeah,
So my requirement is, okay, hear me guys, hear me. So what I'm saying is, I have an application, okay, let's say I have a web application. I have, guys, one second, hold on. Listen to my question.
So the product should also be higher.
Wait. Listen to my question first. First of all, am I audible to everyone?
When you're giving so much of importance, what
Yes.
happens?
Yes. Guys, hold on. Am I audible to everyone?
Here is,
Yes.
Ravi, hold on. I'm asking, actually, making sure everyone is able to hear me. So,
Responding.
I hear many people saying voice is not audible, so that's the reason I'm checking. Am I audible to everyone?
maintenance or production or delivery becomes higher. So that is where when the cost becomes higher, whatever they are trying to sell or give,
Your voice is coming actually somewhere.
so that is where.
Ravi, I think you're playing one of my old video. Can you please go on mute?
Adam, your voice is listening for 2 times. We are able to listen it 2 times.
Yeah,
When you
someone
are
is
speaking,
playing.
Yeah,
No, not that. Someone is
yeah.
playing some video. That is the reason. So is it better now?
Yeah, it is better now. Now we can able to hear properly.
Okay.
Yeah.
Yeah. So I think someone was playing my old videos or something. That's the reason it's my voice again. My question, what it is when we say CI/CD, our interest is we are going to create a artifact which is deployable, because this is where in the traditional method you will generate a jar or a var and you have to manually copy to that machine, and you have to start your application, or you have to start your application server like Tomcat or JBoss. For that you have to write some script or use Jenkins. But traditionally, instead of doing it, we started using Docker based deployment, in which you are going to convert your application into an image by adding the artifacts into the image. And now when I say deployment, all you have to do is take this Docker image, go to a machine and create a container. Then what will happen? As soon as the container runs, your application is also running, and for that, whatever the environment is needed is available inside your image. So that way, now, since we are going to use Docker, so what do you mean by deployment? It is all about creating an image and running that image as a container in a machine of your choice. That is what we call it as deployment. But when I do a deployment on a production level, it may not be a single machine in which I have to do this. So that is where we use an orchestration tool like Kubernetes, in which a group of machines will be, as a cluster. And using a tool like Kubernetes, now instead of you telling on which machine to create a container, you just tell to Kubernetes that, hey, I want to deploy my application. So now what is deployment in Kubernetes? You give the image to Kubernetes, and Kubernetes will try to see whatever the machine is available, and in that machine it will try to create a container from the image what you have given. Now this is what we call it as deployment. This is like from 10,000 feet height how you are trying to explain. But let's get a little deeper and try to understand. Now, what is exactly happening when I say deployment? So here we have generated an image, okay? And on the other side, you have a cluster available. So now tell me, what do you exactly have to do in order to say that you are going to deploy your application which is inside the image? So how do you do this concept of deployment in Kubernetes? So I have given you an image. What else will you do?
We will write the manifest files and then we will deploy accordingly using the Kubernetes manifest file or Helm charts, and then we deploy it to the production wherever it's required.
Okay, that's good. So that's first part of your answer. Now, anyone else? So how do you deploy? So what I'm telling you is, I am giving you a cluster saying that, hey, this is the Kubernetes cluster. And on the other side, I'm saying that this is the image which is available in the Docker registry. So how will you deploy that?
We pull
Guys, I
the
need
Docker image.
Correct. I'm expecting answers from you. See, if you think it's just going to be one way, I'll finish this in another 10 minutes. That's not the whole point. But all I'm trying to do is make sure you're understanding. So please do answer by understanding what I'm asking you. So I'm saying there is a Docker registry in which image is available. And on the other side, there is a Kubernetes cluster. So what is that I want to do the deployment?
We will write a Docker manifest file, Kubernetes manifest file, and we will pull that image, and after that we will create that image, and we will do the deployment to the requirement environment.
Yes. So what you have given is only first half. So all of you are telling the same thing. So pretty much the first thing what you have to do is in Kubernetes, if you want to run your container using an image, then for that, you're going to write some manifest file. Why? Because unlike your Docker, it is not that Kubernetes directly manages a container, because on top of it, there is a layer called pod. Now that has different abilities. So whether you want to run one copy of your container, which is one pod, or do you want the ability to run multiple copies of it? Do you want the ability to scale up or scale down? So that is where there are different objects for that. And that is where we have deployment object or stateful set object or daemon set object. So depending on the type of application and depending on how many replicas that you need, you have to define an object. And then what happens? On top of that, if you want to access this application, so you need to expose a port. Then what kind of application is it? Once again, do you want to access it within your cluster, or do you want to access within a pod, or do you want to access outside your cluster? And that is where there is another object called service, where you have to think of defining it as a cluster IP, or you have to think of it whether it's going to be a node port, or you're going to use a headless service or a load balancer service, right? So there is another object that you have to define. Then like this, there might be multiple things you have to define, probably what volumes you want to take, what configurations that you want to take for the applications, right? Now, pretty much that is what you put everything into a YAML file, which is what we call it as a manifest file. Clear? So that is the first requirement. So when I say deploy, you need to know it is not that blindly you take an image and run it. Depending on how the application is going to be running and what are the properties that you want, you have to define different objects that you need. That is the whole concept of using Kubernetes. So what do? You write a manifest file. Fine. Now, let's say that you did that also. So I have a Docker image in the registry. I have a Kubernetes cluster. Now for this, I have written some YAML file in which there are different objects like pod, deployment, or volume, config map, service, all these things has been written. Okay, what is next? So how do you take this and tell Kubernetes to run? So what will you do for that? Now think logically and answer me. So I have written some files. Assume I am giving you this file. Hey, okay, you want this? So I'm giving you this YAML file with all the details. So how will you run that?
So
We
we'll
manage
use
to
deployment strategy.
Sorry?
We'll use deployment strategy with according to the environment.
What do you mean by deployment strategy?
We have around 4 to 5 deployment strategies that can
That's okay. That's okay.
and
But tell me, what will you do with that? So I'm giving you a file. Tell me more technically. I'm giving you a file now. See, first is, I told you I have a registry, but now rather than referring to the registry and the image, I'm going to write a file called as manifest file, which will have all the details. But what will you do with that file? That is what my question.
With the help of that manifest, we can create the packages.
Okay, after that.
After that, we can deploy in the every different environments by using
How
the
do you
Helm.
deploy? Okay, let's understand this.
GitLab,
we can run kubectl apply -f and the manifest file name, and we can also specify the namespace.
Okay, that's a good answer. So now you need to understand this, that whatever the manifest file I've given, you have to use it and you have to say kubectl and apply -f and this file name, correct? Now, from where will you run it? That is the next question, because your cluster is somewhere else and your manifest file is somewhere else. So how do you connect from your machine to the machine in which you have the kubectl to run? So can I run the kubectl anywhere I want? That won't work, right? So what is that you're going to do for this?
We have to run it.
Get a Groovy script.
We need to apply in local kubeconfig file in which we need to create a certificate through a synchronize between our local laptop or local machine to Kube API.
Exactly. So the whole point again is you have to either go to the cluster or go to the master and try to run the kubectl apply, or pretty much you need to have access to a machine in which you have a kubectl which internally uses a file called kubeconfig file, and that refers to your Kubernetes cluster. So this way, now whatever the traditional method that you would have seen is that you have to first copy these files from the machine where you have written, because now assume I am the one who is writing the manifest file and I'm asking you to just run the kubectl. Then basically you have to take the files, which is the manifest files from me, and you have to go to that particular machine, and from that machine you are going to execute the kubectl. So pretty much you are going inside the cluster and you will be executing. Now for this, what you have to do, and that is where you would be using something like a Jenkins pipeline, or you will just simply do a SSH to the Kubernetes master and copy this file, and then you execute the kubectl apply, right? Now this is what we call it as deployment, and this is what you might have seen different people talking or different ways of executing. But when you try to do all these things in an automated way, so what is going to happen now is you are going to run a pipeline, which is what we call it as CI pipeline, and that CI pipeline is going to basically generate a Docker image whenever there is a change, and this image, how are you going to now apply? So for this, you are going to have some manifest file. Now this has to be updated, right? Because every time you do the build image tag will be updated.
So you cannot have the same build image deployed every time. So how do you differentiate between the previous image and the current image? So every image will have a different tag. So for every build, the tag number will change. So based on that, you have to modify your manifest file to include these image, and you will copy these files into that machine, like a master machine of your Kubernetes cluster or the machine in which you are going to run the kubectl. And for that, you push. So this method is what we call it as a push method. So basically, then you will be running your kubectl command. So that is what we call it as a deployment. Okay. So this is your traditional method where for doing all these things, like I said, you can use Jenkins pipeline or you can use the GitLab pipeline where you need to tell where is that machine in which you are going to execute the kubectl, and for that you need to copy these files into that machine. So this method, which is what traditionally everyone have been using, is called as push method. Okay, so to whatever the pipeline that you have seen, this is what you will do. But now comes the problem is, this is a good method. So this is what people have been doing, and this is what people have been trying to, tell, hey, you build an image, you update your manifest file or create a manifest file with whatever that you need, and that you push it to a machine or a cluster. But think, if the same thing, if I'm asking you to do in production, the user who has access to this pipeline pretty much has also access to the deployment cluster, right? So somehow he can easily hack into the machines, right? Because for running your CD pipeline, you are allowing the pipeline to have all the credentials through which you are allowing it to connect. But this is where there is a loophole, wherein if you are focusing into more a cloud native solution and looking at the security wise, this is not a good practice, because this pipeline has the God mode enabled. So when I say God mode, pretty much you have every credential, right? So now if I have access to this machine or this pipeline, I can easily go inside your Kubernetes cluster, which is a production. And if I can go to your production, I can access each and everything which is running inside it, right? So that is how the biggest problem now we are having is the traditional method, whatever that you have heard so far, where people are saying, okay, you generate manifest file. Yeah, but after that, how do you deploy? No one talks. They will just say, take this file, copy this to a machine and run kubectl apply, right? Then that's not the right way, because you are sharing the entire credentials to the pipeline, because there is going to be a huge risk, especially when you're considering certain factors, that this method is not suitable for production. So that's the first problem that we have in our traditional CI/CD pipeline, and it cannot be a single pipeline. The next problem is, so now this is where I was trying to ask you a question is, if you want to deploy an application, so now for a minute, let's forget about the pipeline, but just think in this way. Now, if I want to deploy in Kubernetes, so I need to have a manifest file. But is it a single manifest file? No. So there is going to be multiple YAML files put together. That is why we call them as manifest. So what do you mean by that? So now, for your deployment, you might have to write a file which defines the pod, another YAML which defines service, another YAML which defines the config map, another YAML which defines the secret. So now, when you are running a pipeline like this, saying I am automating everything, now, when will you do a deployment? When this pipeline is executed. Okay, so that the pipeline, again, when I say pipeline, you can use whatever that you want. You can write a script or a Jenkins file or a GitLab or any other tool like Travis. But the whole concept here is, when you run this pipeline, it will build and it will update the manifest file and it will push. But the concept what I'm trying to bring here is, when are you going to run this pipeline? So traditionally, this is where if you use a tool like Jenkins or GitLab, you would say either you will poll to a repository, and whenever there is a check-in, automatically this will run. Or when you use something like GitLab, you will put a webhook. so that when someone checks into the GitLab repository or pushes to the repository, the webhook triggers the pipeline. So only when the source code is changed, you are actually triggering, if you actually understand. What do you mean by source code? Source code means the actual source which the developers is modifying for the application, like the Java files. So only when that is modified, the pipeline is triggered, correct? But what if now I say, I am a person who wants to access this deployment and I have not modified anything on the source code, but I have a requirement where the application configuration has to be changed. Now, in your Kubernetes deployment, there is something called as config map. So using that, you will be passing some applications properties like what database to use, or what will be the startup, command, or how much of memory to give. So those kind of basic information you will give. Now I want to change that, or even the basic thing, I want to change the log level of my application running. So I'm not changing anything. I want to just change only a particular configuration file, or in my Kubernetes, I want to modify the manifest for config map. Then when I do it, how will this deployment happen? Right? The pipeline will never get triggered because I'm changing something directly here. Then you have to put some kind of monitoring tool which will find out whether your configuration file has been changed, or you have to manually go and trigger, and there should be an ability in the pipeline to do it, which is another problem. So that is where the pipeline will not get triggered by itself when you are trying to change some applications configurations like config map. Not just that. What about if I say that it's very simple, I just want to change my replicas. I don't want to change any of those. I just want to change the replicas. So that is where whatever your application is running, it also has its own environment. So I want to change some service type. I want to change some port number. Then what will happen? Once again, there is no triggering of this particular pipeline, correct? Because I want to just change some user access and I want to trigger. Now those things will also not happen. So that is where the pipeline will get only triggered when you are going to trigger based on a change in the source code. So whether there is an application change or environment change, this will not work. Okay. Now let's talk about another interesting point in the same. Now, every time a new build comes or a new check-in happens, you will generate a new build, new Docker image, and you will deploy. But what if you have a requirement where you want to deploy an old image and run it? Okay. Guys, is my audio, can you hear me?
Yes, Adam.
Yes, Adam.
Clear.
Okay.
Yes,
Few
Adam.
people are just saying, yeah.
We can hear you properly.
Okay, now someone was just saying no audio. So now understand what I'm trying to tell is you have to think practically. So if I am a QA person and suddenly I want to test that yesterday there was a build done, and from that I want to test a functionality. So what will I do? Should I be triggering this pipeline? Because when I trigger this pipeline, what will happen? This will build a new image. So that is not my interest. And moreover, can I go ahead and build it? No, pretty much if you have put it up in such a way that only when new check-in happens, this pipeline will run. So we need a pipeline which can be triggered on a different scenario, and every time I don't want to come from here. So now if I want to just simply take an old image and with all the same properties of the manifest, what will I do? So that is where for all these scenarios, you cannot just use the traditional method of saying CICD, which is one pipeline. Okay. So that would be a foolish thing to do, because practically that cannot happen, because CI and CD is not going to be a single stretch or one pipeline. Okay. So that's the problem that we have. Okay. This is another problem. Now let's talk about one more. Now, whenever you have this kind of pipeline, now tell me, how many clusters will you have in your organization for deploying? Will you have only one? Now think, when I say one cluster, it is nothing but one group of machine, and it is backed up with Kubernetes. Now, for dev, there might be a cluster. For QA, there might be a cluster. And then if you are having a performance team, there might be a different cluster. And then for your UAT or stage, there might be a different cluster. And for production, there might be a different cluster. So now, how will I deploy everything to say that I'm doing a continuous CI/CD? So it is not that as soon as I build, I put it over here, and basically the first deployment that you do as part of your CI will be just for running some basic sanity testing. Okay, so what do you mean by sanity? It is just to verify whether the image is generated properly, whether your manifest is okay. So it is going to be like a very basic build verification testing. That is what we call it as sanity testing. Then where will you do your actual functional testing or regression testing or your UAT? Then everywhere there is different cluster. So now tell me, how will I deploy to that using this pipeline? So do you think now, is it that after this I will just deploy, or where is the pipe after this? So no. So this is not the way that you're going to do. So that way you're going to have multiple pipelines, because as soon as I say in this example, I have a dev cluster, I have a QA cluster, I have a stage cluster and a prod cluster, then at least I have 4 clusters of Kubernetes for my productor. Okay. Now what is happening? So I have 4 clusters. Then for each cluster, I need to have separate manifest file, correct? Then how do I automate it? So pretty much now if you see, CI is 1 pipeline, but CD is 4 pipelines. So for each pipeline, you are going to follow the same process where you will generate or update some manifest and push that to a particular cluster. So that way there will be 1 pipeline for dev, there will be 1 pipeline for QA, 1 for UAT or stage and production. Now this is where the more and more clusters you have, the pipeline keeps on increasing. So that is where it is 1 CI pipeline and multiple CD pipeline. Okay. Now, how do you manage all these things? Which is where using just Jenkins will not solve your problem. Using GitLab will not solve your problem. Or people might say you can use Ansible. There are different ways, but all of them do traditional method of push, which is not secure, and it doesn't help me to trigger whenever there is change. But still, if you try to break it up into multiple pipelines, then there's a lot of effort that you have to put, and there's a lot of monitoring that you have to put, so that depending on what are the changes that you need, you can think of deploying it in a different way. So then holistically, all the requirements will be fulfilled. So it is not just that one pipeline will solve all your needs. Okay. Now, this is again for a simple architecture. What if you have a complex microservice architecture where I don't just have one image, I have multiple images? Then if I have to do a deployment, it is not just I build one image and deploy. I might have to have 2 images and I want to deploy both of them. And in that, again, same problem. If I have 2 pipelines put together for one deployment, how will I know what has been modified, what has not been modified? So there's going to be a lot of complexity and lot of overhead in monitoring and setting up the pipelines. Okay, so this is the state where we are currently in. Maybe you might have not gone through, but think this is what is going to happen, because you are not going to just take all your files and push to your Kubernetes cluster in your traditional method. Okay, so this is where, what's the solution that we are going to bring in? Okay, so the solution for that is GitOps. Okay, so what is GitOps? Now, the name has the answer. So GitOps, is basically just a practice. Now again, it's not something new, or it is not something like a whole new technology, like what people think. Okay, DevOps, like how we have DevOps, GitOps is another technology. No, it's just a best practice. Okay, so it's more about ensuring that whatever the problems that you have, you can solve all of them by using Git as one of the facilitator. Okay, so the entire operations work, whatever we are talking, so you can use Git to solve all this problem. Okay, Now, how do you do it? Now, this is where the concept of GitOps, okay, let me again repeat. So what is GitOps? So GitOps is nothing but a practice in which you use Git and couple of other things in a a better way to achieve a modern CI/CD. Okay, so that is what that concept is called as GitOps. Now for this, the first best practice that we are going to say, so if you are going to adopt to GitOps, you need to make sure first you describe whatever that you need in a declarative way. So what do you mean by declarative? So if you are trying to write a pipeline, maybe if you are using a Jenkins pipeline, then you have a concept of writing everything in a declarative pipeline using your Groovy syntax. The same thing if you're going to use GitLab, then again, there is a YAML file in which you define different stages. So pretty much whatever that you need for your deployment, define it declaratively. Okay. But when you say declare or declaratively, it is not only about the build and generating the image, but along with it, if there is an infrastructure requirement that you need, you can also think of it by writing it in a declarative way. So that is where if you are trying to use cloud, then think of using some tools like Terraform, where you can declaratively define your infrastructure. So there are some organizations where you might have to create or customize your infrastructure before doing a deployment. Then whatever that is needed. So whether it is your actual pipeline to do the CI or whether you want to create an infrastructure, think of using Git, and for that write all your code declaratively. Okay. Now, when you say write it declaratively, this is where you need to adapt to a concept, which is what I was trying to tell you is, now if you are going to use Jenkins, then not to use the traditional, what you call the freestyle job, but use the Jenkins pipeline wherein you write a file called Jenkins file. Same way, if you are using Terraform, then try to write all your configurations in your, the whatever the HCL file that we take with .tf. So that way you define everything declaratively. But this is where what happens is the concept of storing all these things. So now, if you have to write declaratively, so there is not just one set of files you might have to write. So you need to understand for your deployment, there is one application repository that you're going to maintain, wherein you are going to put all your source code and whatever is needed for your deployment in terms of the declarative concept, you're going to write your Kubernetes manifest file, or if you're using Helm chart, then try to write the templates. So this is where you're going to have an application repository specifically in which you are going to store all the declarative code for the deployment. But to support that, whatever the environment that you need, then once again, you are going to have a separate repository for it, wherein all your infrastructure needs and networking and service mesh or monitoring stuffs which is needed for your Kubernetes deployment, you put it here. Like your Kubernetes file is here, but your Terraform code and service mesh like Ishito code, those kind of things will go here, right? If you're having some monitoring stuff for Prometheus, you put it here. Now what will happen? The second point here is, once you have differentiated the requirement into two phases, one is application repository, which will have these code, and you have an environment repository, which will have these code separated. And when you write a code, you are writing it declaratively. But where are you going to store? Now that is where use Git as the single source of truth. So what do you mean by single source of truth? So you have to maintain it somewhere. So which is where Git is going to come into the picture. So you're going to store all of them into a Git repository. So what is the advantage of this? Now, any point of time, if you want to take the file, all you have to do is a git clone and you will get everything from this repository. And you can also do versioning, which means any changes that you are doing can be easily trackable. Okay. And not just that, you are also going to get back if you need a content from this easily, right? Suppose I want to quickly roll back to a previous environment. I have everything available in this, which is why we call it as a single source of truth. Okay. Now, instead of keeping it anywhere, now whatever the files that you need for your entire deployment system, you put it into respective repositories and store it into Git. But when I say Git, you need to have a central repository tool or a version controlling manager like GitLab or Bitbucket or GitHub, whatever is that you use. So there you are going to store into separate repositories. So that is what is the next point, which we call it as single source of truth. Okay, then what happens? Okay, so you have defined everything that you need, but how are you actually implementing this concept? So this is where what you're going to do is you're going to define what exactly is that you need as a desired state into these files. So now assume that I have a stateless application and I need 2 pods, and for that I will take a particular image from a particular private registry, and supporting it I might need a config map, and I might need also some kind of let's say service definition volumes. So what exactly do I need that should be running in my Kubernetes cluster? You define everything into this respective repository. So depending on whether you are telling something about environment or whether you are telling something about your application, now like I said, you put the changes or the exact configurations on how your desired state will look in the Kubernetes cluster into this respective repository. So now if I say that, okay, I want 2 pods with a particular image and a particular port to be exposed, a particular service to be available, and a config map, then I put all of them defined as the respective manifest into application repository. And if I have anything related to the environment, I put it here. Okay, so this way you define your desired state. Then whenever there is a word called desired state, then there should be another way that there is an actual state which is running in your cluster, correct? Now this is where you have your Kubernetes cluster in which the actual state should be maintained. So how do you do that? Now that is where in the traditional method what we were doing, so you were doing the same concept, but you were copying into it and you were doing a kubectl apply. Only then the actual state was maintained, because you define your desired state in the manifest, but how did you apply? So you took it, you went into that machine and you kept the file and then you did the apply. So that is where push was happening, or the push mechanism. But in GitOps, what happens is you are going to store your desired state in a particular repository as a single source of truth. But how do you make sure that the actual state is obtained with respect to this? So this is where in GitOps, what we will be doing is, in order to make sure, okay, if my desired state for my application is I need some object like deployment with 2 replicas, some load balancer type of service, a config map and pod, then in order to make this, we are going to use something called as an operator, which is what we call it as GitOps Operator. So what is that going to do? So instead of you doing a push, we are going to introduce this operator, where this operator will be monitoring your particular repository. And whenever there is a change in any of this repository, it is going to automatically update the cluster with the actual state. And that is where the difference now is, instead of going with the traditional push mechanism, you are going to do a pull mechanism. So how does it solve all the previous problem? First thing, when you are writing your CI pipeline, you generate the artifact like Docker registry and you store it. And for your deployment, whatever the manifest that you need for Kubernetes and supporting it, the configuration files, whatever it is, you put into a particular application repository. And anything that is needed for your environment, again, you put it as a declarative code in the respective repository. And you tell to this operator to monitor all of them. So that is where, unlike your traditional method where there is only one pipeline, now if you are doing a build and the build will generate a new image and you will update the manifest file. So stop it there. You don't have to do anything. So whenever there is a change in the repository, the operator will find out and say, okay, this person has modified this file. Now let me take this file and compare with what I have in the actual state. If there is a difference, then it will take this file and update and apply. So you don't have to give any credentials from your pipeline. So your pipeline is safe and your pipeline ends only by generating a Docker image and updating the manifest file. Okay. However, like I said, the previous problem, this is not the only case where my deployment should happen. So I might either build a new image, or either I might have to change my configuration file, or I might have to change the image name, or I have to do some environment change. So whatever it is needed, you go to your Git repository like a regular user, or the user can just modify the repository and the operator will check all the repositories together. So that way, any one of the source of truth has been modified, automatically the operator will pull the details, match with your existing state or the actual state, and if it doesn't match, it will apply. So that way, you don't need anything separate, and this can be achieved for multiple pipelines also. Now that is where, by using a GitOps operator, you are going to perform a pull-based approach, wherein you store everything into respective repository and your CI pipeline will just ensure that build has happened. It will store into the registry and it will try to modify and update the respective manifest saying, this is the image I want to deploy. Or respectively, when I want to change something in my environment, I will change my Terraform scripts and put it here. So for any change that is happening here, the operator will pull it. So that's what we call it as GitOps. Okay, but it doesn't stop it here. Now I was telling another question that, okay, are we deploying only to one environment like dev? Now I have 4 clusters. So how do you solve? So that is where in the GitOps operator, what you can do is, rather than just checking one repository in Git, if you look very closely in Git, you have multiple branches. So that is where for each environment or each cluster that you have, you put different branches here and store the code. So for example, I can use the master branch for production code. That means anything that I want to deploy into production, that code I can take it from master. For dev, I can create a new branch called dev and maintain all the code. For QA, I can create a new branch called QA and store all the code. So that way, my CI pipeline will generate the image and update the manifest file on dev branch. And if someone from QA wants to do a deployment and they want to modify by just saying that, hey, I want to take this image, so they will go to the QA branch of this repository and they will modify the manifest file. So this way, your source of truth for different environments is maintained by separate branch in that repository. So I don't even need multiple repo. One repository for an application with different branches where each branch is pointing to a cluster's content. And that you can tell it to operator in the GitOps. So I can tell the GitOps operator that, look, for dev cluster, you have to monitor the dev branch. For production cluster, you have to monitor the master branch. So that way, you can use a single operator to specify what to monitor from the Git repository with respect to a branch and to which repository that it has to apply. So pretty much the credentials, whatever you have to do, will be separated. So a user who is interested to generate this manifest file, like you are a build engineer or you are a DevOps engineer who is focusing only on generating the manifest, then you need credentials only to modify, right? So your CI pipeline doesn't need anything beyond it. All you need to do is modify this file in a respective branch. Same way, if you are a support engineer or a QA engineer, you need access only to that particular branch in the repository where you modify the file. You don't need access to the Kubernetes cluster at all to do deployment, right? So how can you do those user permissions in Git? That is where if you use a tool like GitLab, you can pretty much protect the branch, and we can tell who has the permission to check in, who has the permission to merge. Those kind of concepts can also be handled. So it's going to be very simple, where the user authentication is also possible, and user should not think beyond modifying this file. So as a user, whether I am a developer or running a CI pipeline, or I'm interested to do some QA deployment or stage or production, my interest is to only to modify the manifest which defines the desired state. And internally, the GitOps operator will pull from it. So from one location, you can try to read the content and ensure you are going to deploy and make the actual state available. Okay, so that is how GitOps helps us to ensure that it is a simple way, and you can set up multiple pipelines with just one operator, and with just one repository you can have different branches. Okay, so this is the whole concept of GitOps. So the same pipeline whatever I was showing you earlier, now let's try to see how in a GitOps way it will work. So what you are going to do, so you're going to have a CI pipeline in which you're going to just, whenever a check-in happens or a push happens, you build and you generate an image. After this, what you will do, you will update your registry, which is one method. But after that, you might also have to maintain different repositories in which you will be updating the manifest, right? So if it is a CI pipeline, I build this build image, I will be referring into a application repository, because again, just for simple understanding, I have mentioned one repository, but understand this is going to be multiple repositories. One is the actual application, the other one is infra repository. So now, based on whatever the changes you want, you update it here. Okay, now whenever there is a change either in the registry or in the repository, you need now as an operator who will be monitoring this. So that is where you will have the operator inside your cluster. So specific, suppose if you are having a dev cluster or a QA cluster, you will have an operator which is a GitOps operator running inside this. So what will this operator do? Now the CI pipeline, where does it end? It ends here. So it will build, it will put into registry, or it will also update some particular manifest file in the repository. So that is where your CI ends. But what does the CD pipeline do? So the CD pipeline is taken care by this operator. So this operator will be continuously observing on, is there a new image uploaded, or is there a new file which has been modified in any one of your repository, like whether you have modified your manifest for Kubernetes, or have you modified any application configurations, or have you modified any environment, image name, or replicas. So that way it will be monitoring all of them, and if any one of them is changed, then it means that you have modified your desired state. Then what is the actual state? It will look, and based on the difference, it will take the content from the Git, and in that, which repository and which branch we will be telling. So basically it will be observing exactly that branch in the repository, and whenever you have modified your desired state in terms of these, then it will go ahead and then take it and deploy it into your cluster. Okay, so this is how the same, I can just have another operator, or the same operator I can say go and deploy. If you find, if the branch is dev, then go to this cluster and deploy. And the same thing, if the change is happening in prod, then I have to define. So that is how the CD pipeline will be handled by the operator, where you can tell all these options separately. So this way, now understand your CI stops here, and CD starts here. So that is how this is just one pipeline, whereas like this you can have separate pipelines for each of the cluster. So I can have one operator and a cluster for each of the Kubernetes cluster for dev or QA or stage or production. Okay, and this way you will get all the benefits where a user doesn't even have to worry about giving credentials. And now if I am a QA, if I am not going to do any of this, all I'm going to do is there is already a manifest file in which I want to change my image to an old one, or I want to change some replicas. Then I will go to this repository directly and I will go to the particular branch where I have my access, and then I will modify this manifest and check in. And as soon as you do that, the respective operator will check, oh, there is a change found in the QA branch of the repository, and in that there are some files modified, which means your desired state is different and your actual state is different. So it will take and then deploy. So this way, it's easy for us to maintain the credentials. It is easy for us to manage different flows based on different triggers. And it's also easy for us to have multiple pipelines because you are separating the CI with CD. So this concept where you are going to use Git repository as a single source or single source of truth, and having different branches to maintain different environments content. Okay, and ensuring that you are using an operator which will do the CD pipeline. Okay, so this concept is called as GitOps CICD. So basically, this is also the regular CICD, but the just difference is the way that you're handling will be better, and you can have multiple pipelines in an easier way. Okay, now this is what every organization is moving towards, and that is where for this you need to have the basic understanding of what is CI/CD, that is regular, but you need to know how the declarative pipeline will be defined, and you basically have to know what is Git. And now when you say Git is just the client side, but where do you maintain all of the repositories? So you need a central manager or a repository manager, which is where one of the popular tool like GitLab is getting, very popular because of its UI. So using that, you will be able to manage. So whether there is a change in the source code, or whether there is a change in your manifest file of application or deployment, or if there is an environment change, for everything there will be a trigger of deployment which is going to happen on the other side, and users doesn't have to worry, or we don't have to worry about giving them access. Getting it? So this is what we call it as GitOps. Okay, very simple. But this is where we need to understand what are the types of operator. So just by using Jenkins, you cannot achieve everything. Now, what is happening in production, we need to definitely have some operators. And that's when it depends on what type of, strategy that you are using for deployment. And for that, if you are just using, the regular manifest file, then you can use GitLab to store. But if not, there are different operators available. If you are ideally moved into Helm-based package management for Kubernetes, then there is a Helm operator in Kubernetes which you can use to achieve the same. But if not, there are pretty much many other tools available. Now, out of all those things, you might have heard about Spinnaker, okay, but that's kind of a heavy tool. And that's where there are two tools which are quite popular in the market, okay, which is Argo CD and Flex CD. Now, out of this, Flex CD is not again scalable as of now, because Flex CD has the ability, or the operator in the Flex CD has the ability to just connect to one cluster at a time. That is, in this diagram, if I use Flex, you will have one operator associated to one cluster. Now, as my initial requirement was 4 clusters, then I have to have 4 separate setup of operators. So that is where Flux is more suitable only if you are into dev environment. But one of the actual popular tool, which you can explore is Argo CD. Now, it's just my suggestion where Argo CD is quite suitable for most of the complex requirements, where I can use one instance of Argo CD which can connect to different clusters. And that is where Argo CD works better for most of the modern requirements. And using this, you can deploy or maintain whatever your different strategies that you need. Okay. And the another good thing with Argo CD is you have a wonderful dashboard, because all I'm talking about is deploying, where instead of you telling this will take care of the files and put it up, but what if some issues are happening? How will you debug? And this is where there are a lot of dashboards available. I do see people keep saying you will use the kubectl dashboard, but that is more of not a matured one to give you all the details. And that is where a tool like a GitOps Operator, which is Argo CD, also has built-in dashboard, okay, wherein you deploy it automatically, and at the same time you can see everything, what is the issue, without even going to the cluster. So that is where a user doesn't need to have any access to any of the cluster. So you can just use the dashboard and you can maintain everything from this. Okay, clear so far on what exactly is this, or GitOps, or any questions?
Hi, Adam. It means Jenkins is not playing any kind of role on GitOps.
No, Jenkins is also playing. So this is where you need to understand, we are not trying to replace anything which is available, because who is going to trigger this part?
Okay.
Who is
For
going to
initial,
help you updating this? So you need some tool, right? Which is where Jenkins is going to come. So CI is what Jenkins will do. So Jenkins is not a CI/CD tool. Jenkins is a CI tool. Okay. So pretty much for you to trigger a pipeline automatically when a check-in happens, do the build. And again, if you actually look into the pipeline of CI, I've just given it simple. But for those who have gone through, you would know that within this itself, you would have unit test, you would have code coverage, you would have to do code analysis, then you have to do scanning, and then you have to verify by doing a quality check, or what we call it as quality gates. And then you have to push this into a artifactory like JFrog Artifactory or Nexus, and then you are going to run a Docker image creation and push into registry. So for all these things, you need an automation, which is where you can think of using Jenkins or GitLab, which is going to help you in setting up CI.
Yeah, I have a small note, if you allow me. I noticed that you put manifest in the same repository of the code, and that I prefer to save it in separate repository, because 3 weeks now, 3 weeks points I can mention. First week point, that it's risk, because all the developers that has allow permission in the code can reach also the manifest files and can play whatever they need.
I
Second point,
understand.
yeah, second
No, I
point,
understand that. So yeah, sorry for that. So the point, it's a good question that you said. Yeah, it's ideally, if you see, it's just for explaining it simple, but that's actually a good point that you catched. So I cannot put everything together, but when I say application repository, you might have more than one repository, which is exactly the whole point of using Git. So it's not necessary for me to store everything, but the concept of when I said application repository, you need to have one set of repository where the users have access, because in modern pipelines or in organization, the deployment is also done by developers. So I don't need a separate person to do the deployment. So in that case, the whole concept here is you can either have a single repository to maintain, but as you said, if you have a concern where I don't want developers to do all those things, then you can separate this so that the application repository itself is two. So there is one where you can keep only the source code and build related files, or for any kind of build and deployment related, you can keep another repository, but all of them are generally called as application repository. Okay, so that's how it is. Okay, clear? All right. So how do we achieve it? All right. Now, this is where let's get into some demo.